Here is the motor in question. There at the bottom. Oh goodness. She's a heavy little thing. Get up here on my autopsy table and we'll start taking it apart. Okay, here's my little Transit Connect. It's a small van. I do a lot of work out of it though, and fuel economy. That's why I do it. So there's a little truck tour. Keep all my PVC fittings in these baskets. I got 6 of them. All kinds of unions, PVC fittings, everything else. Keep a little pop-up shelter tent when it's raining or too sunny. Cords, hoses. My shop vacs back there. Got an inverter that powers my printer here, which is sitting on this top box is full of unions, and the bottom box is full of specialty fittings. What we're after here today is, this heavy. This is all just tools. This box, which has all my motor repair parts in it. So we'll get in here and we're gonna do a wheel and run on this sucker right here. First thing we're gonna do is, well, turn on this GoPro. We're gonna pull the suction flange off of this pump. And it's got maybe 8 screws. Never counted. Guess we will today. Yeah, it's 8. This is a AlphaFlow XP2, FM XP2 actually. And I haven't even looked at the horsepower on it. It's a pretty big motor. It's like 10 amps. So it's like 2.6 or something. Let's see what she says. It's a 2.6 full rate. So that's 11.4 amps on high speed, which for you folks that like wattage, it'd be about 2,500 watts. So there's the suction flange, seals with a single O-ring. And we've got the wear ring here. I've explained this in other videos. What this does is it rides on the nose of the impeller. When the pump comes on, it pushes forward and seals the impeller to the suction flange so you don't have circulation inside the pump. So now that guy's off there. Set this stuff aside. Make some witness marks. Just some scratches. And that is going to aid us when we go to reassemble this motor, if we reassemble it. See if your through bolts will come out. And we'll knock the Zen bell off of the motor. That end bell is off. Let's go around and get the rest of the rotor out. Pop loose. So that's the sweet nectar we're after. That's what's locked up. Let's do a little inspection of the coils down in here. They look good. Not burned up or cooked or anything. Everything's nice and bright. This right here This is starter switch. So what this does is engages the starter coils and sends power to a capacitor up here. And that's regulated by, this is like a governor. So right now, if this was installed, this actuator would be pushing these two switches in, powering those circuits. As soon as the motor got to speed, these flyweights fly away, that actuator drops back, and it turns those switches off. When those break or go bad, this motor will just cook within about 30 seconds or so. This has got like stamped steel ones. Some of them have pot metal ones, which are pressed metal. And over time, these hooks straighten out or break off, and that's the death of the motor, and they usually fail in spectacular fashion. Let's pop that together and set him aside. The next thing we need to do is get the impeller off. Now, if it was in good condition, if this motor was in good condition, we'd be able to just, with just the strength of our hands, just unscrew that impeller. But it's not in good condition, it's in really poor condition. And that's actually what's locked up. So the motor itself isn't bad. I'll show you what happened to it in a second. There is a feature on the back of these impellers called a dielectric sleeve, and its purpose is to prevent water from coming in contact with the metal shaft. When the shaft seal leaks, water leaks around the dielectrics. When the shaft seal leaks, the shaft itself rusts, and it rust jacks, and it splits that dielectric sleeve. This impeller's not coming off like this. This impeller's coming off with a hammer and chisel. I didn't feel like looking for a chisel, so we use this big old flathead screwdriver. It's like a Tootsie Pop. So there's a brass insert in here, 9/16. Once we get the plastic off the impeller, this was molded into the impeller. We can get to that, and hopefully, might need a shorter extension. There we go. So there's that brass insert. So that was molded into the impeller. So we busted the impeller off. We were able to get to that, get it unscrewed. That's not what's bound up. What's bound up is still on there. It's just a plastic sleeve. All right, so we're gonna have to bust some more stuff up. Being careful not to mess up the motor shaft itself. Man, there we go. Okay, so now this should not be stuck inside of here like this. This just actually should be free. So this is what the whole problem was. See if we can get the whole thing to come out as an assembly here. So what happened was, this is the dielectric sleeve. And you can see it, the shaft rusted, a rust jack that split that sleeve open. So that thing opened up like a collet, but in reverse. And grabbed the hold of the inner part of the seal. The ceramic part, you can see it's actually cracked it and broken it. So it's a $15 part, took out a $500 pump. We'll knock the seal out of here because this wet end is still good. It just needs a new impeller. Set that out of our way. Ready these tools. The next step in this process is going to be disassembling this. The next step in this process is taking this end valve off. And all we need to do there is loosen this one screw. We didn't need to do all that. And the way I get these off is I spin them and hit them at the same time. There we go. Now, let me find that keeper and that screw that came out of it. We'll put that back together. The way this works is you've got this little keeper here. And when you tighten the screw, you've got this little keeper here. And when you tighten the screw, the keeper turns sideways and that keeps the bearing bottomed out in that end valve. That wasn't the smoothest pull we've ever done. This fell off. There's a shim that goes right there. And so I don't forget it, I'm just going to go ahead and put the rear bearing on right now. I either use Nachi or Timken. Nachis are Japanese made. They're very high quality bearings. Normally when I'm in the field, I just use my alignment pliers to do this. Since we're in the garage today, little tap to get it started. This is a 203 driver, made specifically for these 203 bearings to fit on this size shaft. And it doesn't take much force to drive them on. Just kind of holding that motor down with my forearm, that rotor down with my forearm. There we go. So there's the rear bearing replaced. Now for the front bearing. I use this 3/8 inch deep socket to protect the armature, the threads. And on these motors, the cooling fan is too close to the back of the bearing. You can't get a puller on there. You need to use an adapter like this. I didn't think that little 1/4 inch drive impact was going to pull that for a second. She was definitely putting up a fight. And there's your bearing. The bearing actually doesn't feel bad. The rear one, a little bit crunchy, but they're not horrible. I've seen much worse in running motors. We'll go ahead and get this front one knocked on here. You can hear when they hit that shoulder and they're all the way on. I'm going to take a break to clean up a little bit and we'll be back. We're back from a break and we're ready to start putting this pump back together. So the very first thing we're going to do, let me get y'all where you can see good, is we're going to get y'all where you can see good. I'm going to put this end belt on. She's a little snug. You might need a little bit of love here. Huh. Well, we'll need a lot of love. It's kind of awkward, this position I'm working in, because I'm trying to do it so the cameras can see. There we go. She went right on. We'll tighten up this keeper here. It's going to hold our bearing. That's done. Set this guy to the side. Here's the motor barrel. Pop that end belt off. That rotor in there. And we're going to look for our witness marks we made when we first started. And just gotta rotate this just a hair. Spin this around. Make sure there's a wavy washer that goes in the back of this. Make sure that's where it's supposed to be. Line these witness marks up. Slide our through bolts through. Nice. If you don't put those witness marks on when you're taking it apart, it's not that it's impossible to get these in. I mean, they're put in at the factory. There's no witness marks, but we don't have any kind of jig or anything, so it takes a little bit of looking down through trying to look through those little holes and see the hole on the other end with a light in front of it. Get them lined up. They're in. Let me find some nuts for those. Had some nuts on hand because we're not going to be putting a wet end back on this immediately, and we want these bolts to stay in here. Sweet. spins nice. And I'm going to call it quits for today, and we will be fooling with this again tomorrow. The whole point of this video was, will it run? We took a motor from a job, changed out the bearings in it, inspected it, cleaned it, and we're going to see if she runs. I think it probably will. Here's our motor. She's wired up. You don't even want to see what I did there because it ain't cool, but it's for testing purposes. All right, let's turn the power on and see if she runs. That's low speed. She's running good. One thing we have to do here, is clean this shaft off. Now, I'm just going to use a file. I'm sure there's guys out there in YouTube land that are YouTube machinists that are just like, oh my God. That shaft is looking pretty good. We don't really have to worry about this pitting on the shaft itself. It's way stronger than what it needs to be for the load that's on it. And then all of the bearing of the impeller is right here on this shoulder and these threads. The dielectric sleeve just simply goes back and covers the metal shaft. So there's nothing bearing on this part of the shaft. It's all right here, which is untouched. So she's in good shape there. We're going to switch the motor over to high speed. That was low speed we just ran. That's 1725 RPM. Let's try it on high speed. Here's how she sounds. Oh man, she sounds beautiful. No run out or wobbling in that shaft. The point of the video was, will it run? And yes, it will run. It'll run really good.